What is the functional group of an alkyne? Well, alkynes have got triple bonds, so let's look over that, a triple bond between two carbons. What is the general formula for an alkyne? It's going to be CnH2n minus 2. So CnH2n plus 2 would be an alkane. Without anything, just CnH2n is an alkene, and an alkyne is that over there. Alkynes are not officially in the curriculum, but they do kind of flow quite nicely from alkanes and alkenes, so I've kind of kept them there a bit. Define an isomer. Isomers are compounds which have the same molecular formula but a different structural formula. Which of the above diagrams is a molecular formula? So we're looking at all of these over here, and the molecular formula is A. Which of them is a semi-structural formula? That is, you haven't got all the structures, but you can see more or less what's on each carbon, so that's going to be D. And which of them is a full structural formula, and that's going to be your B over there, over there. Which of the following pairs are not isomers? So now you basically need to draw these out in order to establish what's going on. So if I take a look at these now, you can see that you've got butane, 4 carbons over there, and here is methyl pentane, sorry, not methyl, yeah, methyl propane. And each of them, if you count it out, you get C4H10 for both of them. But2-ene and but1-ene, the double bond has just moved, but it's going to be C4H8 for both of them. Over here, hexane, 6 carbons, and all alkanes, so it's C6H14. Dimethylbutane, 4 carbons with 2 methyl groups on it, C6H14. So these are isomers. Yes, yes, yes. The next one, let's hope, isn't an isomer. It's hexene, which has got a double bond, which means it's C6H12, versus methylpentane, which is C6H14 because it's an alkane, and therefore those two are not isomers of each other. What elements are found in hydrocarbons? Hydrogen and carbon. What happens to the boiling points and melting points of alkanes as carbon chains get longer? They are going to increase because the intermolecular forces increase. Which intermolecular forces exist between alkane molecules? Well, they're non-polar molecules, so they're held together by London forces. What causes larger hydrocarbons to have stronger intermolecular forces? They are going to have more electrons in them, and that's more points of contact and more place for mini dipoles. So that is, the molecule has more electrons, therefore there is more electron wobble or electrostatic points of attraction. Let's just look at the others. The molecule is more polar, while the hydrocarbons are not polar. The molecule has more atoms and therefore is more symmetrical. The more symmetrical it is, in fact, the lower the melting point is going to get, and the weaker the intermolecular forces will be. And the molecules are more likely to be solids at room temperature. It's a very nice story about strong intermolecular forces, but it's not what causes it. So B is your best answer. What is the distinguishing functional group of an alkane? It's when you've got single bonds between all the carbons and all the hydrogens on the carbon chain. What's the distinguishing feature of an alkene? We've got at least one double bond on the carbon chain. And then we've got those diagrams that were there a short while ago, which was exactly the same in both of the quizzes, so we're not going to worry about that too much. And then what is the formula of an ethyl substituent? An ethyl substituent is going to be C2H5 hanging off a chain, so the best answer there is A, except that these should be C subscripts, so that should be CH3, that should be C2H6, not that they're the right answer, but still, and that should be CH4, they should be subscripts always.